So let us look into the first question. Which type of okay, one more thing, the questions, see, the question we are not trying to answer because the question will repeat. The question we are discussing, so this will give you an idea what kind of questions will appear and what are the area you can focus. My suggestion will be at least revise the topic from where the question has come. Okay, even if you know the question answer, this question number 3, if you know the answer, it doesn't help you. But what does gonna help you is, let's say there's a question on this. So now let's go back home again and revise the topic from where the question come back. Okay, so the question may not be the same, but there's a good chance a related question from the same topic may come. Okay, so that's the whole intention of discussing this. So let us see the question number 3. Which type of drag does arise from resolved component of tangential stress on the surface of body when the viscous fluid flow along the surfaces? So I'm not sure whether you understood the question or not. So let me first explain you the question, what the question is. So let's take an aerodynamic body. Okay, aerofoil is the best candidate for that. And if air is flowing over the aerofoil, what happens is there are two types of forces acting on the aerofoil. One is tangential and one is normal. So normal is the pressure force and tangential one is the shear stress. So tau is your shear stress. So that is what they are interested in. This tangential stress is nothing but your shear stress. So they're asking which type of drag arises. So best way of doing is try to eliminate the options. So trailing edge vortex, no, trailing edge vortex doesn't come from this, it's come from the trailing edge vortex. Wave drag also doesn't come because the wave drag comes from the shock wave. Surface friction drag, yes, this is the guy which is comes from the shear stress. And last one is a boundary layer normal pressure drag. Normal pressure drag is actually because of this component. So the correct answer would be the C. So now you know the answer is C, but which topic you need to revise? So you go back to the aerodynamic book and look for the flow over a aerofoil or fundamental of aerofoil. If you read the topic, you automatically will get answer for this question. Just let me know if you don't understand anything so that I can explain in easier term. But if it is okay for you, we can go to the next question. Okay. Okay, let's go forward. Next question. Yeah. So let's look at the question number 14. So it says, guys, can you see the full screen? Or still showing you with the PPT and all that?
Showing sir all the PPT, sir. It's not in full screen. It's not in PPT presentation mode.
Yes. Actually, yeah, that is the issue sometime with this. I don't know why it doesn't do that. Okay, just let me. Try to share something else. Okay, I'll try to maximize as much as possible. I can't do anything more than that. Okay. I think this is the maximum view. I can't go more than that. Okay, so let's look into this question. So there's a flat plate of 1 meter and width of 5 meter. So this kind of question you can always start with drawing the sketch. Okay, so there's a plate which has a length of 1 meter. So this is 1 meter and the width is 0.5. So let's say plate is something like this. So this thing is 0.5 meter and it's placed in an air stream of 30 degree blowing parallel to it. So there's a air which is blowing parallel to it. So it has a temperature of 30 degrees Celsius. The convective heat transfer coefficient H. I hope you are familiar with the basic heat transfer. So I guess you if not that, you guys kindly just revise the basic conduction, convection and radiation. Just basic BTech stuff, nothing too complicated. Watt meter square per Kelvin, that is here. Now, what is the heat transfer if plate is maintained at a temperature of 300 degree? So I guess on the bottom side temperature is 300 degrees Celsius and top side, sorry, temperature is maintained at 300 degrees Celsius and the convection is happening outside. So your air is at 30 degree and plate is at 300 degrees Celsius. So I will say my delta T across plate and the air will be 300 minus 30 degree. Okay, so this will be of course before you do that, it's always in difference. So either you do in Kelvin or degree Celsius, it doesn't change, it will gonna remain same. So I will say directly 270 Kelvin because even if you convert it, it's still gonna come same only. So now Q is HA dt. So what they're asking is the heat transfer. So heat transfer is nothing but Q HA dt. So H is 30, area is the cross sectional area, so 1 into 0.5 and the temperature is 270. Guys, does anybody have calculator with you? Can you
Sir,
just
it is coming 4.05 kilowatt.
4.05 kilowatt. So it's easy. So answer would be the B. So if I see, this is pretty standard BTech stuff, basic heat transfer, nothing complicated here. So similar kind of question you can expect. I don't think this is from aerodynamics. This might be from general heat transfer, anything. This is a basic, even the first year knowledge itself, you can do this kind of question. Okay. So shall we go to the next?
Yes, sir.
Okay. Yeah, this is the same thing. I was just trying something back. So answer is 4.05. Yeah, this one is slightly roughly you can say BTech level only, but from the GATE syllabus directly. Does anybody know the answer for this? Question number 26.
Sir, it is Biot-Savart law that says, sir, I think when the current
Okay,
is
I
flowing,
have. Yeah, tell me.
I think it's related with if the current is flowing in a conductor, this magnetic field induced at some particular point, something like that, sir. So we have, and also we have said with the vertex it is there, or vertex is there, it is inducing the velocity at a particular point at some distance from it. So some.
Yes, Uttam, your intuitions are right. So I will guess your answer you have chosen is correctly, but still I'll suggest just look for the topic in aerodynamics, finite wing theory, and this topic start with the Biot-Savart law only. What this tells you that if you have a vertex filament, okay, which contains a lot of filament vertex, and the velocity induced by the filament at any point P, which is at a radial distance of r from the vertex, whose strength is gamma. So the vertex or the induced velocity can be given by dv is equal to gamma upon 4 pi dl into r vector rq vector. The reason I'm asking everybody to revise this is they have just picked up the topic. So they have asked one question. There's a good chance they'll ask another question, not the same but different question, but from the same topic. So the correct answer is Biot-Savart law. This is the formula, and it is same as if you look in electrical engineering, the magnetic field induced by the current conductor carrying a current. It is the same formula but modified for the induced velocity. So my suggestion will be just once again revise the topic. Okay. Any question on this?
Sir, but Biot-Savart's law has it's called magnetic flux density we take out. It's dB. So it's dV here is the velocity, is the vortex. Okay, understood, sir.
Yes, Anand, that is, it's not directly taken parallelly as it is. Like we just take the formula from electrical engineering and just modify our number. The formula has been derived based on
Derived.
some other assumption within the aerodynamics.
Understood,
So
understood, sir. This
yeah,
dV represents the vortex.
no, dv represents the velocity induced at point P, which
Okay.
is at a distance r from the vertex, which has the strength of gamma.
Okay.
So dv is actually velocity.
Sir, this
Just like,
this is like nu
yeah.
naught in the electrical thing. That
I
constant, I believe.
might be. I'm not too good electrical, but it could be. But I know the formula has a similar form.
Similar form, yes, sir. Exactly,
Yes.
almost similar form, sir. Yes.
Yes, there's a 4 pi in the denominator. There is a length vector. There's a positional vector. There is a cube.
dl by r square, sir.
Yes, and in front of gamma, there's a, I guess, current is there or something is there. Yeah.
New, yes, sir.
So, but it's very close. It's only to remember, but actually, there's a very huge derivation to judge this formula also. So that's the reason I'm just trying to give you a hint that just look into once again to the basics. So it will be easier for you to answer any other question related to this topic. See, the reason I know this because I teach aerodynamics on regular basis, so I already know this formula exists in this. But for you, since you have very short time, very quickly, so you may not pick up that fast. So better to just go to the topic. So we will know, okay, at least we have covered what has been asked. So from your end, you can be satisfied yourself that, okay, we didn't leave anything unprepared.
Understood.
Okay. So any other question? Okay, then shall we go to the next question, guys?
Yes, sir.
Okay. Okay, this is pure fluid dynamics. So we have a studied state flow, and they're asking which of above statements are correct. So let us see how many statements are correct, and then we will accordingly pick the option. So they say the magnitude and direction of velocity vector at all points are fixed invariant of time. So that is true. For the steady flow, the magnitude and direction of the velocity vector does not change. So if the flow look like this, so at any time the particle here will have the velocity in this direction, and at this point particle will have velocity in this direction. At here particle will have velocity in this direction. It doesn't change with respect to time. So this is true. The streamlines are different from the path lines. No, for the steady flow, streamline and path line both are same. So I can say this is wrong. Streamline and path line are identical. So this is true. So I know my first and three will be true. So this again, once again, give you one more idea that you need to go through the basic definition of flow. How many types of flow? What is the unsteady flow? What is the steady flow? What is the viscous flow? What is the inviscid flow? And rotational flow, irrotational flow. Like this, there are certain classification, some 6 to 8 classification are there. Just go through them, make sure that you understand them. See here, nobody is going to ask you the definition of it. When you read something, you need to understand the physics behind it or what the statement is trying to say, rather than just simply memorizing the definition. Okay, so that you have to keep in mind. So let's go to the next question. Any question, guys, here?
No,
Okay.
sir. We can move forward, sir.
Yeah, let's go to the next one. Yes, so this is boundary layer over a flat plate. So let's look into the question. So we have a flow over a small flat plate that is 5 centimeter long. So this is the plate, length is 5 centimeter long and 1 meter wide. So this is something like this. This is 1 meter and the length is 5 centimeter. Free stream condition correspond to a standard sea level and the flow velocity is 120 meter per second. So there is a velocity here 120 meter per second, and they're asking you have to assume the laminar flow. So this is a good hint to tell us, yes, what type of flow we are dealing with and what is the boundary layer thickness at the downstream edge. So this is the leading edge, this is a trailing edge. So they're asking what is the boundary layer thickness at this point. If you are aware of this, boundary layer grows like this and finally becomes stable. So they're asking this height. This height has a formula. Okay, does anybody remember the formula for the boundary layer thickness of a laminar flow?
Yes, sir. It is equal to 5x upon under root of Reynolds number.
5 into x divided by square root of Reynolds number into x, where x is the distance from the leading edge, the where you want to calculate the boundary layer thickness. So in your case, x is nothing but 5 centimeter. Okay, now first thing is this formula need to be remember. So it's not normal, everybody don't remember this formula. This formula is only applicable for a laminar flow. Okay, and it comes from the Blassier solution. So you need to revise what is the formula for boundary layer thickness for the laminar flow as well as for the turbulent flow now, because today they might have asked laminar, in the next exam they might ask for the turbulent flow. And not only the boundary layer thickness, there are momentum thickness, there's energy thickness, 2-3 formulas are there. You will get them in fluid dynamics book, any standard fluid dynamics you will get it, but in Bansal also it is there. I've seen it when you study the laminar flow boundary layer thickness, there you will get it. So that you can revise later. Now we'll focus on the formula here first. Now what is the formula for Reynolds number? Does anybody remember? Based on the x?
Yes, sir.
Anyone?
Rho V x upon dynamic viscosity.
Mu. Okay, so rho is the density, v is the velocity, x is the distance based on which you are trying to calculate the Reynolds number, and mu is the viscosity. Okay, now they have given the dynamic viscosity, and this is which type of viscosity?
The dynamic viscosity.
Are you sure?
Sir, dynamic viscosity divided by density, that is kinematic viscosity, and this
Yeah,
one is
sorry.
actually.
Yeah. My mistake. Yes, sorry. This is the dynamics. I was thinking this is the kinetic. The kinematics after dividing is correct. Sorry, my mistake. So this is your dynamic viscosity. So now you can substitute dynamic viscosity and this is the density, this is dynamic viscosity, and velocity is 120 meter per second. X is your 5 centimeter. This you have to convert into meter. Please keep that in mind. Okay. Once you complete it, then substitute back into the density. Can somebody tell me what is the value of boundary layer thickness here?
Uh, Sir, I'm getting 3.9 into 10 to the power minus 4. Um that
Tell me your answer. 3 point.
3.9 into 10 to the power minus 4. That is actually, sir, close to last answer, but not sure. I mean, so I
Just
have to.
let me verify. Well, actually, you are very close. I also got same thing, 3.83. So that's the reason I want to do parallelly cross check you. So what we'll do is we'll not worry about the options here. We'll just pick up the closest answer. So closest answer would be the 4. So you can always pick up the 4 and go ahead with this, because there's no other way of choosing. This is a objective type question, so you always have to pick up the closest answer. And this question is straightforward. There's no trick here, so you cannot make any mistake. Best case scenario, what you can do is, see, the more precise formula is, instead of 5, there's a 4.91. so we have tried both, so it doesn't work. You are as best as 4 only. So we'll just take that answer and go ahead with it. So don't worry too much about what was the answer. You just make sure that your concepts are clear and you're using the right formula. Okay. Shall we go to the next question?
Yes, sir.
Okay. Yeah. So the next question is about the stream flow, stream function. See, what I have seen the question, based on that, what I realized was, in general, see, already you're looking at some of the topics that's gonna come or might have come earlier. But my general observation was, they're also following the GATE syllabus only. They don't have anything else. For the namesake, they have released their own syllabus, but their question was nowhere related to those. Their question were related to the GATE syllabus only. So this stream function also is one of the topic. When you study the fluid dynamics or the aerodynamics, you start with the stream function, potential function are the first thing that you study. So here, since the question has come on the stream function, I will advise to revise stream function as well as the potential function. Okay, please revise these two topics. They're very simple topic, very simple. There's nothing complicated in the topics. So once you read it, maybe in a 3-4 hour span, you can finish them. Okay. So let us see. So simple definition for a stream function is, radial velocity is given by 1 upon r d psi by d theta. So this psi is your stream function. Okay. So now they already given you the radial velocity. So Vr is given and they're asking the stream function. Of course, they given the boundary condition also. V theta is equal to 0 when theta is 0. Of course, we'll not need that. Way before that, we'll get the answer. So what you have to do is substitute the V r here, keep 1 by r d psi by d theta. So once you throw that r on that side, you get yourself, I guess I made a mistake here. Yeah, sorry, cos theta should be no, this is right, sorry, my mistake, this is right only. So what I just reshuffled it, so d psi by dt is equal to k r. If you send other side, it will be in the numerator, so you end up with the denominator will go off, you end up with the square root of r k square root of r cos theta. Then you, once you integrate it, you get psi k square root of integration of cos theta, because k and r are the constant one, so they will go out of it. Once you integrate the cos theta, you get k square root of r sin theta plus c, this constant. Now since boundary condition is already given that v theta is equal to theta is equal to 0, so once we substitute the boundary condition, the c will go to the 0. Finally our final function will be psi equals to k square root of r sin theta. So that is the one of the answer already given in the list. So that is your answer D. Okay, so anytime you need a stream function, all you can do is just either differentiate or integrate with respect to the variable given. Okay, once you do that, then you should be okay to go ahead. Okay, any question, guys? Anyone? So shall we go to the next one? Yeah, so this question actually related to the gas dynamics. If you look at the GATE syllabus, it will be given something as a compressible flow. Okay, so let's look at the question. So they're saying there's a air flowing in a high speed wind tunnel. Now this is the hint for you to prepare. You know, there's a question in the wind tunnel, so kindly prepare the what is wind tunnel, how many types of wind tunnel, what are the basic operations of wind tunnel. This thing kind of thing you should be aware of. Okay, so there's a pressure and temperature given by this number. So pressure is 0.3 atm and temperature is negative 100 degrees Celsius. What is the specific volume? So before you calculate it, you need to know what is specific volume. Specific volume is nothing but 1 over the density. So all you need to do is calculate the density. So what is the formula for density? P by RT. Pressure is already known, 0.3 atm. Now can somebody tell me what's wrong with the question? Can you identify the mistake in the question?
Sorry, it is the temperature that is given minus 100 degrees Celsius.
Minus 100 degrees, okay, that's possible. Even when we do the experiment and in the wind tunnel, if the flow accelerate too much, you might get 100 degrees Celsius. That's not a problem. Minus 100 degrees is a possible temperature. What is the other mistake?
Hello, sir. The maybe the air flowing at high speed is written, but the pressure is only 0.3 atmospheres. Is
That's
it
correct.
not?
When the air blows at high speed, the pressure is going to reduce. So pressure
Okay.
and velocity are inversely proportional. Once the pressure velocity goes high, pressure
The
is
pressure
supposed
reduces.
to go
Okay.
down.
Okay. Yes. Yes.
So that is right part. Anything else you see a mistake? It's a very what you call popular one. You can't make that mistake. You're not supposed to make that mistake. Of course, the problem is you can't tell anybody this. If there's a mistake, there's a mistake. You cannot challenge the DGCA for this part, but there's a mistake in the question. Can you identify it? ATM is equal to kPa. Okay, now I will ask you a simple question. Let me know. 1 ATM is equal to how much Pascal? Can somebody answer this?
Sir, 10
No,
to the
Anil.
power 5.
Anil, you are wrong. Please re-verify that. Yeah, Anand, what you are telling? 10 to the power
5, sir.
5. Do you see the value given here?
Yes, sir. It's given -5.
10 to the minus 5. Newton per meter square is okay because Pascal is nothing but Newton per meter square. That's all okay. But the 10 to the minus 5 is not okay. It is 1 ATM is equal to, even if they want to give 1.01, it's supposed to be 1.01 into 10 to the power minus, sorry, again I'm doing the same mistake, 10 to the power 5 Pascal. It should not be a negative one. Okay, that's the mistake they're doing. Okay, and Anil, sorry, it is not 1.01 kp, it is 101 kpa. If you want to remember in terms of 1 kp, 1 ATM is equal to 101 kpa. Okay, so now let's start with the solution. Now you know everything. You have the pressure, you have the R. What is the value of R? Anybody?
For air, sir, it is 287.
Correct. So now just substitute the R's. Before you convert pressure, it should be into the Pascal. So 101 also you can take. Temperature should be in Kelvin. And then R should be as a 287. Can you substitute everything? Get the value of density, reverse it, and tell me the value of specific density.
Oh, sir, I have got this value 1.63 into 10 to the power -10. As
How come?
I don't know, sir. I actually took this -5 in my while calculating. So
Can you redo it? I know many students don't pay attention to the. Sometimes they will think it's all whatever they are given is right only. So please try to consider the correct number and then redo it. Just check it again. Take it plus 5.
sir, it's coming 1.63 meter cube per
Perfect.
kg.
Yes. Anil, you got it? I also got 1.65, but that's okay. It's closest to the 1.6. Okay. Let us see the next question. Yeah. Any question, guys, on this? Can we go ahead?
Yes, sir. We can move, sir.
Okay. Okay. So next question we have a again from gas dynamics. So at a point in an airflow, the pressure is 1 atm. This time they have not given the atm to bar conversion or Pascal conversion, but you know that already. You don't need that. Temperature is 320 K and velocity is 1000 meter per second. And they're asking what is the total temperature? T naught. Already given the gamma is a 1.4. and value of R is 287. So does anybody know the formula for T naught?
Sir, for if we consider compressible flow, the formula will be T naught equal T naught the total pressure divided by static pressure 1 plus gamma minus 1 by 2 into Mach number square.
Okay, see, you don't have a pressure here, total pressure. All you have is the static pressure. So you have to come up with some other formula. Any other formula which connects between the given parameter what we have?
Yes, sir. Like I'm telling, sir, total pressure divided by the static pressure equal to 1 plus gamma minus 1 by 2 Mach number square. So here it is asking for total pressure. I'm sorry, total temperature, and we have the static temperature that is 320. We have to find the gamma is given for air 1.4. We have to find the Mach number here. We have to calculate it. So that is B upon gamma under root gamma RT. So I think everything is given. We have to just calculate it.
I think you are going too long. There's a direct formula for it. Can you think again?
That T
It's a
static
direct
plus
formula.
half V square upon Cp. Does this work?
Yes, that one. See, there's a direct formula which connects the total temperature with the static temperature. I don't know what is happening to the PPT. It's going blank. Okay, yeah, it is there. So total to static temperature is equal to static temperature plus V square by 2 Cp. Is everybody familiar with this formula?
Yes, sir.
Okay, that's good. Just use it directly.
Here, sir, we have to calculate the CP also, and for that we should knew the formula of CP.
I will suggest you know, since at air, you directly take the value of Cp as 1005.
Okay, sir.
You know, the since here the gamma is 1.4 and R is 287, so pretty much it is gonna remain same. You can verify also. Just let me write down that formula, that Cp is equal to gamma R upon gamma minus 1. With this formula, you can verify the gamma value also, in
D,
case
option D,
there's any doubt.
17.8.
Anil, regarding calculator, I'm really not sure. You can check up the advertisement. Have they given any hint in there whether what kind of calculator they're allowed or not? Because there are two possibility. If they allow you scientific calculator, then they might give you complicated questions. But if they give you only the digital calculator, it means the numerical will be simpler. Only the conceptual will be more favored rather than the complicated situation. That's actually much better, because they want to test you for your knowledge, not for your mathematics. Okay.
Sir, as I think, sir, virtual calculator is allowed because without sir calculator, even some question take like more.
Yes, even this simple question also nobody can do. Yes, yes, is expected. They should give you the virtual calculator at least. Okay, guys, everybody got the answer? What is the answer here? 817. My answer is 817. I'm not sure about yours. So, shall we go to the next question?
Yes, sir.
Okay. Okay, so we have the last question here. For Fanno flow curve, the subsonic region of friction causes what kind of features? So just simply giving the answer should not be the correct way of explaining this. You should always look for this diagram. When you open up the Fanno flow, what happens in Fanno flow is, if let's take you take a simple duct, okay, and if there's a friction, then, and if the incoming flow is subsonic, the outcoming flow will be still subsonic, but M2 will be higher than M1. So flow will accelerate. This tells you general features of the subsonic flow. In the Fanno is nothing but flow with the addition of the friction. So this branch is subsonic. So as you add more and more friction, what happens is entropy increases. Okay. So if you're moving towards right, it means you're adding more friction and entropy is increasing. So the Mach number actually increases and reaches towards sonic. One point will come when you add enough friction, your flow will become sonic at the end. So with that understanding, you can answer this question that for a Fanno flow, first identify what happened in Fanno flow. There is a irreversibility. Okay, so irreversibility in all four of them, so nothing to do with it. But the flow accelerates. So there are two acceleration possible here and here. And when the flow accelerates, pressure drops. So with that, I can choose my answer to be C. So if you know the Fanno flow, this diagram, if you revise the Fanno flow, then it's pretty standard. Then anybody will know. Okay. So yeah, there's one more question. Before we go, guys, any question on this? We have one more question after that, but let us first clarify this one. Then only we'll move forward. Guys, can we go to the next question?
Sir, when the supersonic, when it's in supersonic, the entropy created will bring it down to sonic, basically.
Sorry, can you repeat that?
Sir, the supersonic, when we go from supersonic, sir, during supersonic flow, sir, uh, the entropy will be very high here, you're saying.
Yes.
So that will reduce it to sonic flow, basically.
Okay, so you're trying to ask instead of being subsonic, if the
Yes.
flow was supersonic M1, then once it goes through a friction duct, it will try to go sonic, but if you don't put enough, it will still be supersonic, but M2 will be less than M1. For supersonic, it will decelerate.
Okay.
So Mach 0.3 will try to reach 1 and Mach 2 will also try to reach 1. So either way, the flow will go towards 1 only. So subsonic flow will
That's what
accelerate
I
and
was
supersonic
asking.
flow will decelerate.
The subsonic curves also tries to reach the one, and the supersonic also tries to reach one basically. So,
Right.
huh, okay. So now I understand the graph basically. Thank you, sir.
Yes, yes. So my suggestion would be, don't just focus on the one question that you answered this correctly, you know the answer, be happy and go home. Try to revise the whole topic.
Sir,
So at least if there's any resemblance or any pattern in the question, you will be able to catch the question in time. Okay. Any other question, guys? Can we go to the next one? Okay, Anand. So next we have a question: across a strong normal shock, the ratio of density after the shock to that of before the shock attains a value of. This question is actually partially written. It's not completely written. There should be some more statement, but okay, we will try to answer this. So what they're trying to say is, there's a normal shock, and you know that the flow before the normal shock is always supersonic and flow after the normal shock is always subsonic. Please remember that. Then the density rho 1 here and rho 2 here. They're asking the density ratio rho 2 by rho 1 is, what is the formula? A, B, C and D. So answer is C. The question is how. Many students, those who are currently preparing for GATE, they remember this by heart. For them there is no issue. Problem with if you are revising long back. So for this kind of question, what you are supposed to do is remember this formula. This formula is important. This is required for the normal shock, and they're asking, they didn't tell that, they're only telling a strong normal shock. Okay, so strong normal shock means it could be any Mach number. So what you can do is you can test this by substituting m1 as an infinity. To substitute m1 as infinity, we divide numerator and denominator by m1 square. So we get gamma plus 1 on top, gamma minus 1 plus 2 by 1 upon m square. So once you put m1 square as infinity, you get this term as a 0. You end up with rho 2 by rho 1 as a gamma plus 1 by gamma minus 1. So answer should be C. Okay. So with that, you can always choose the answer. For this, to answer this question, you need to have the basics from the gas dynamics. If you don't have that, there's no way you can know what is the correct answer. Okay. And definitely there's a 100% guarantee that this question will never come back. Once they give one question in previous year, they don't repeat it. So don't hope that this question will come, I will memorize it. Never memorize anything. Just try to understand it. See how you can answer a question related to that. So that's all the question, guys, with me for whatever has happened appear previously. If you still have any other questions, please feel free to ask. I will answer it. Otherwise, we will have next class on Friday. There we will try to see what are the experimental experience that I have. Rather than being that as a lecture, I cannot teach that part, but I will share my experience of the testing we do in aerodynamics field, propulsion, combustion field. Those kind of experience I will share with you in the next class. Okay. So if you have any question, please feel free to ask. Otherwise, we will close the class today and we'll meet up on the Friday again.
Sir, on the basis of the syllabus, could you please
Sorry,
guide us
sorry,
through,
Anand.
sir, on
Can
the
you repeat
basis of
that?
the syllabus? Sir, on the basis of
Uh,
the syllabus, could you guide us through a little on what topic should we more focus on more like, matlab, uh, it's time,
Yes,
so
okay. That I will try to do in the next class. I will, because right now I don't have syllabus with me, but I will get it from the Dinesh and I will
sir,
look into it. All I got from Dinesh was the industrial topic as a one of the syllabus, so it looks ridiculous to me. I will try to get the full syllabus. I will go through it once, and then I can advise you that okay, pay more attention to this, which is already you have studied related to you, and something
mhm,
which is more like completely out of the picture, you have never seen it. Then there's no point in breaking the head on that topic.
mhm. Sir,
So definitely, I'll try to touch that in the next class.
sir, could you actually go back to that stream function and potential function question again, sir? My computer went off, sir, at that point of time.
Sure, sure, sure. Here, this is the one.
Sir, sir.
So what you do is take the fundamental formula for the stream function. The radial velocity in terms of stream function is 1 upon r d psi by d theta. And then just you already know the VR, you need the psi. Just integrate it. There's a constant c, but since boundary condition is itself is 0, you can ignore that and you can pick up the option D as a final answer. K square root of r sine theta.
Okay. Okay, sir.
Okay.
Okay, sir.
Any other question, guys? Don't worry, you still have 2 days to prepare. Sorry, not 2 days, 1 day to prepare. Friday again we will meet. If anything which you forgot to ask today, you can again ask on the Friday,
Sir,
and I'll try to see what I can share with you what I have learned so far. And with that, I hope you might get some useful information which might help you in the interview. Okay. Any other question, guys? So if there are no question, then we'll close it and we'll meet up on the Friday again. Okay. Okay. Good night, guys.